So the basic kind of rule for conditional probability is given to you at the top of your paper. It's good to know, but I follow more of a pattern than the rule. So what this is saying is finding the probability of A. The straight up and down line in math means given. So we're finding the probability of A given B. Okay? And that basic rule is the intersection of those two events divided by the second event. What does this upside down U stand for again, if we were to like translate that? Does it mean and or? And, right? So this is saying the probability of A and B, so probability of both, divided by the probability of the second. That's the general rule. Okay? What this rule means is whenever you have conditional probability, okay, that means what's the probability that event A will happen given that event B has happened. Okay? This means when you find the probability of event A given B, you are not choosing from all the possible outcomes or the total, the sample space. We're not looking at everything. Okay? We are only choosing from all the outcomes that fall into event B. Okay? So we're narrowing down our pool of what we're pulling from when we find probability. Okay? So instead of looking at the total sample space, we're only looking at event B. In other words, event B becomes your new sample space. One way of looking at it is that the event that is second in the conditional statement will then be the denominator of your fraction. Okay? So when it's something given something, the second thing becomes your new sample space. And that total will go into the bottom of your fraction. And then you're only looking at that category or that event. You're not looking at everything. Okay, with conditional. We kind of already did conditional probability a little bit in the first unit, which is our first section. It just was worded a little bit differently. So we take a look at an example. Example 1 says an experiment is run where a number from 1 to 10, or numbers from 1 to 10 are picked at random. We want to write out the sample space. Call it set S. Well, we're picking a random number from 1 to 10. What are all the outcomes that could be in our sample space? What are we going to write down?
All numbers from 1 to 10.
Yeah, all the numbers 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, your sample space is all the possible outcomes. So those are all of our possible outcomes. You can get a 1, a 2, a 3, a 4, a 5, 6, 7, 8, a 9, or 8, 10. Okay, that's what we can get. Set B is picking an even number. So we're going to look at our sample space. And we're going to write down set B. What are all my even numbers in my sample space? And 1, 2, 4, 6, 8, and 10. Those are all my even numbers. That's set B. Okay. Set A is picking a multiple of 3. Find the probability of getting set or event A. In other words, find the probability of picking a multiple of 3. So there's no condition on this. It just says probability of A. So when there's no condition on it, you're looking at the total possible outcome, the actual sample space. How many elements are in our sample space? 10. So 10 is going to go to the bottom. Of those 10, how many are a multiple of 3? 3 is a multiple of 3. What else is a multiple of 3? 6. What else is a multiple of 9? So 3 out of the 10 fall into event A. So as a decimal, 10 divided by 3 is just 0.30. So about a 30% chance of picking a multiple of 3. Okay. D has a condition on it. It's saying find the probability of A given B. Okay? This means find the probability of A, which is a multiple of 3. So find the probability of a multiple of 3 given that an even number has been picked. So when there's a condition on it, we're not looking at every single possible outcome. We're only looking at the outcomes of the second thing, B. So B now becomes our new sample space. So we are only looking at set B. And of those, well, first, how many elements are in set B? What's going to go on the bottom of my fraction? 5. That's our new sample space. There's 5 elements in set B. Of those, how many fit in event A? A multiple of 3. 1. There's only one multiple of 3. So there's a 1 out of 5 chance that you will get a multiple of 3 if you picked an even number. Right. There's a condition on it. And as a decimal, 1 divided by 5 is just 0.2. I don't even know why I put squiggly lines. It should be actual equal sign there. So 20% chance of getting a multiple of 3 if you picked an even number. Questions over that? The big thing to remember is the second thing becomes your new sample space. It becomes your new total. Okay. Questions over that? We look at it in terms of a table. Okay, we're going to revisit this two-way frequency chart we talked about in the previous lesson, where 52 graduating seniors were surveyed to the about their post-grad plans, and the results are sorted by gender. What are we missing in our table? What do we not have? The totals. So we don't have the totals, we have to fill them in. Okay, so we're going to write total here. And total column on the bottom. Okay, so we'll go across 16 plus 13. Total number of going to colleges, 29. Total for not going to college, 14 plus 9 is 23. Adding down here, 16 plus 14 for total males is 30. And total for females, 13 plus 9 is 22. To get the overall total, you just pick one. I always pick the one on the side. This side right here. 29 plus 23 is what? 52. Your bottom column should also add to 52. And 30 plus 22 is 50. You only add this one side up to get the overall total. If you add up everything on the bottom, you're double counting. Okay? And that matches. That matches what they said in the directions. 52 students were surveyed. I got 52. I'm good. Okay. So then we're going to find the probability of the following. And M stands for male, F stands for female, C stands for going to college, N stands for not going to college. Okay, so probability of C, probability of going to college. Is there a condition on this? Is there a line and then another letter? No, there's no condition. So we're just finding probability like we normally have. Right? Meaning the entire population is your sample space. So what's going to go on the bottom of our fraction? Thanks, Andrew. What's going to go on the bottom? 52. The entire population goes in the bottom. Of those 52, how many went to college? 29. And as a decimal, what is 29 over 52? What do we get here? 29 divided by 52. 0.56. So about 56% of the entire population is going to college. Of the 52 that were surveyed, about 56% are going to college. Okay. If we take a look at B, now there's a condition on it. It's saying what? Find the probability of going to college given they're female. So the female is picked. What's the probability they're going to college? Okay. So that means you go to the second thing, female. We are only looking at the female column. Nothing else. So females, the total number of females is now our sample space. It's our total population. So now it's going to go on the bottom of our fraction. 22. Very good. The total number of females, the second thing goes in the bottom. Of those females, so in this column, how many are going to college? 13. 13 out of the 22. females are going to college. What is 13 over 22? That's a decimal. What is it? Is it 0.59? 5.9. I'm thinking, when you said 5.9, I was thinking 9.5. And I was like, that's all the numbers around. 0.59. That makes more sense. I was thinking 9.5. About 59, almost 60% of the population of females are going to college. If we take a look at C again, we have a condition. Find the probability of going to college given the person picked is male. So again, we go to the second thing. We are only looking at that column. We're only looking at males. So what's going to go in the bottom of our fraction? 30. Total number of males now goes in the bottom. Of those males, how many are going to college? 16. 16 out of the 30. And that is about what as a decimal? 0.53? About 53% of the males are going to college. Well, if we take a look at D, isn't it going to be the same answer? They're the same exact letters. Why aren't they going to do the same answer? Well, here, what did we pull from? What population? What was second? Male, right? We pulled from the male population. Well, what population are we pulling from here? Going to college. So we are pulling from a totally different population because C is now second. And the whatever second is always your denominator. So that means we are only looking at going to college. That's it. Okay, so now it's going to go on the bottom of our fraction. 29. Of those 29, how many are male? 16. So the top number stays the same, but because we have a different overall population, that changes. Yes? Wait like a second. What is 16 divided by 29? As a decimal. What? 0.55. So 55% of the people going to college are going to be male. Okay. Questions over there? Okay, flip it over. Go right. Recall from the front that this is conditional probability is stated as A given B. Probability of A given B. When completing word problem, seeing the word given indicates that you are going to be using conditional probability to solve. Okay? So given is one of those words that is going to help you figure out how to solve the problem. Or something similar to given. Like other words might be like you know. Okay? That's another trigger word. That means the same thing as given. Like what's the probability of getting an A if you know you study? Okay, that's the same as given. What's the probability of getting an A given you study? So something like you know, or we're told, things like that. That means the same thing as given. Okay? An example 4 says there are 230 sophomores that take geometry, 206 sophomores that take algebra 2, and 32 sophomores that take both geometry and algebra 2. Find the probability of selecting a sophomore that takes algebra 2, given they also take geometry. That's telling me, see that word given? I'm doing conditional probability. So I like to write out kind of the formula for it a little bit. So whatever comes before the word given goes first in your conditional statement. Okay, so what came before the word given? Algebra 2. Algebra 2. Given, what came after given? Geometry. So that's going to go after my line, because that line means given. So I like to do that because it helps us visualize what's going to go on the bottom and what goes on the top. Okay? So geometry is second. So the total for geometry is going to go on the bottom of my fraction. That's my new total. Okay? How many total sophomores are taking geometry?
No.
230. 230 sophomores are taking algebra or geometry. Okay? Of those 230, how many are also taking algebra 2? 32. Okay? Okay? I like to think the thing that has both always goes in the top with the word problem. So whatever is second, whatever comes after the word given goes in the bottom. Whatever has both goes in the top. Okay? Because it's of those people taking geometry, how many are also taking algebra 2? Both. And that's 32. It's really tempting to think, oh, algebra over geometry, 206 over 230. Nope. You're putting people in there that don't fit in that category. So it's the second over, or both over the second thing. Okay. Questions? Oh, and then as a decimal, that's about what? What do we get? What is it? Yes. 2 decimals. 0.42? 0.14. Thought that was a little. 0.14. About 14%. Yeah, that would not have been 0.42. 14% of that people taking geometry are also taking algebra. Questions over that? Okay. The senior class is 55% female and 32% are females who play competitive sport. Find the probability that a student plays a competitive sport given that the student is female. We have this word given. Let's write our conditional statement. What comes before the word given? What kind of topic or category? Competitive sport, right? So you can write competitive, you can write sport, doesn't matter. Okay. What comes after given? What topic? Okay. So when we find that conditional probability, female is second. And this time around, we were given percents. So we're given percents, we have to write those decimals. So what percent overall of the population is female? 55. So that's going to go on the bottom. But what's 55% as a decimal? 0.55. Again, if you don't remember how to convert, just do 55 divided by 100, and that will give it to you as a decimal. Divide that by 100. What's going to go on the top? Of those females, how many also play a competitive sport? What percent? 32. Yeah, a little hint. That's the only other number in the problem. So it's probably what I'm going to use. Okay? 32. What's 32% as a decimal? 0.32. When we have whole numbers, I don't mind if you leave it as an unsimplified fraction or not as a decimal. So when it's decimal over decimal, we have to divide that. I think if my numbers are in percents, my answer has to be in a percent. So what do we get when we do 0.32 divided by 0.55? 58%, 0.58. So then to get it as a percent, if you left it as 0.58, that's fine. But just multiply it by 100, and that will give it to you as a percent, 58%. So 58% of the females play competitive. Questions over that? So we won't do all of them, we'll do 3 of them. So here a survey was taken to examine the relationship between hair color and eye color. The chart shows the portion of the people surveyed who fell in each category. Okay? If a person was picked at random, find the following. So here, they didn't give us the numbers. They gave us the percents as decimals. This is like saying like 15% of the people had blue eyes and black hair. Okay? 20% have blue eyes and black hair. Okay, those aren't 0.15% of a person. Can't have that. They already kind of found the probabilities or the percents for you. They just put it in a table. Okay? So, but the process is still the same. What are we missing from our table? Totals. So let's find them. Okay? Don't have the totals, find them. So for blue, what do we get when we add those three up? 0.15 plus 0.20 plus 0.05 is what? 0.40. Good. For brown, 0.25 plus 0.10 plus nothing. 0.35. Add the bottom up for green. What do we get? 0.25. What do we add the total for black hair? What do we get? 0.45. What do we get for blonde hair? 0.35. And what do we get for red hair? Okay. Again, to get the overall total, you always add one column. I always add the one on the side. So 0.4 plus 0.35 plus 0.25 equals. We should get 1. And these are probabilities. And all probabilities of the same sample space should always add 1. That is right. Okay. 1 or 100%. So that's okay that it adds to 1 because these are just percents. They're not the actual number of people who have that colored hair. It's the percent of people who have that hair color or eye color. So we take a look at A. It says find the probability the person picked had brown eyes given they had blonde hair. Let's write that conditional statement. What's going to go first? What came before given? Brown eyes. Given what came after given? Blonde hair. So instead of our fraction, what's going to go on the bottom of our fraction? What came second? Blonde, right? What's the total percent or decimal for blonde hair? Yeah, because blonde is second. So we're only looking at the blonde column. And 0.35 is the total for blonde. All those people had blonde hair. How many had brown eyes? 0.10. And again, please don't leave it like that. What is decimal over decimal divided in your calculator? What's 0.10 divided by 0.35? Divided by 0.35. What is it? 0.29. So about 29% of the people who had blonde hair also have brown. I feel like we're doing pretty good with conditional, so let's take a look at C. B is just like A. So you're saying, what is the probability the person picked at random has green eyes or red hair? Is this a conditional probability? The word given there? No. Your trigger word for this problem is the word or. Okay? When you have the word or, you use that formula. Probability of A plus the probability of B minus the probability of both. Okay? The word or means to use that formula, and you'll have that formula. You won't have conditional, so you have to remember that pattern. So you will have or. Okay? So let's think. What's representing our A? The first thing they told us was green eyes, so probability of green. Plus the second thing, which was red hair, so that's the probability of red. Minus the probability of both things having green eyes and red hair, whenever you see the word or. So we go through, what was the total for green? 0.25. Plus, what's the total for red? 0.20. Minus, what's the total for both having green eyes and red hair? Where do they intersect on the table? 0.15. And again, and is where they intersect. The totals for both is where that have both. Okay, so where they intersect on the table. And then you just plug that in your calculator. 0.25 plus 0.20 minus 0.15 is what? What is it? 0.30. So about 30% of that entire population that was surveyed has either green eyes or they have red hair. Questions over that? One more. B says, what is the probability that a person picked at random has blue eyes and blonde hair? Do we need to use that formula for D if this is and? No. That's, again, when you see the word and, that's where they intersect on the table. So you go put your finger on blue, put another one on blonde, and then go to where they intersect on the table. And they intersect at 0.20. About 20% have blue eyes and blonde hair. Questions over that?